My name is Dr. Farhan Riaz, and this is the computer vision course that I'm teaching at the National University of Sciences and Technology. I'm using the slides that have been prepared by Professor James Hayes as part of computer vision course that is being offered at Georgia Tech University. Now let us consider an example image over here on which we will perform the Harris corner detection. So as a first step, we will calculate the corner response R, and this is calculated according to the formula that we have already discussed over here at every particular pixel location. And once we have calculated this corner response R, this is how this is somewhat called as the heat plot, where the red regions are indicating the candidates for corners, and so on. So all these red regions have been identified over here. Now, if you remember, we have to calculate the local maxima in a specific region of a particular size. So if we want to calculate the local maxima, or if we do calculate the local maxima, these are the set of points that we obtain after calculating these local maxima. And these points, when they are mapped onto the image, they correspond to these locations. So you can easily see over here, the corners are very effectively calculated at mostly the locations which actually correspond to the corners in the images. So this method works very well. The important things that we need to remember about the calculation of the corners is that we want to calculate the corner locations which are invariant to photometric transformations and covariate to geometric transformations. And what do these terms mean? Invariance means that if the image is transformed and the corner locations do not change, so all those corresponding points in the transformed image should be effectively identified. And by covariance, what we mean is that if we have two transformed versions of the same images, the features should be detected at the corresponding locations, and there should not be any change in that. So these are the two important properties that should be followed by these corner detection methods. So let us briefly discuss these properties that we have told you before. The property of invariance. So let us talk about an affine intensity change. Let's say that we had an image and we have performed a linear transformation on it such that we scale the image and then shift it by a particular factor. As you can see here, this is the intensity scaling, and this is the shifting in intensity, and this is how they can be drawn over here. So we can see that in this case, these 3 points were actually detected as corners, whereas after the image has been transformed, we retain these 3 points, whereas another point has been added to this. So we can say that this method is partially invariant to affine intensity change, and in some extreme cases it might not be, where maybe the scaling factor is very large. In that case it may not stay invariant. Now the second thing is the image translation. So if we have this image over here and it is transformed such that this corner now comes at this particular location, the derivatives and window function, they are shift invariant, and therefore the corner location is covariate with respect to translation. So it doesn't matter where the location of the corner is going to be, we will always be able to detect the corner at the right location. And then the third transformation that we want to talk about is the image translation. Over here we see that is the image rotation, sorry. So this is the corner over here, and the corner has been rotated. If we as we have already discussed about this thing, that once we are calculating the matrix M, we are basically emulating an ellipse which has a major axis, or and a minor axis. So if the eigenvalues of both the two eigenvalues of this matrix, they are both large, then it is going to be a corner. So irrespective of the type of rotation that we apply over here, this is always going to be an ellipse, and this will in effect rotate the ellipse at a particular angle. And if both the eigenvalues had a large value, the corresponding eigenvalues even after image rotation are going to be large. So we can say that the corner location is covariate with respect to rotation changes. Last but not the least, this is the last property that we want to talk about, which is the scaling property. So let's say we have this image in which this was supposed to be the corner that was detected. Now, if we have scaled the image by a big margin, this is how the scaling looks like. And if you can see over here, the size of the window is the same over here at both of these locations. So all the points in this case, if the window size stays the same, all these points will start to correspond to the edges, and therefore the corners will not be detected if the image has been scaled. So we can say that the corner location is not invariant to scaling changes in the images.